시간이 다 됐으므로 오늘 세미나를 시작하도록 하겠습니다. 데스크 위에 있는 동시통역 그 채널 7은 한국어이고요. 그리고 채널 8, there is an interpreter device. The channel 8 is for English speakers. 입니다. 안녕하세요, 여러분. 저는 오늘 UK Country Day 세미나에 참석해 주셔서 감사합니다. 저는 주한 영국 대사관 산업통상부의 무역 총괄을 담당하고 있는 신디 킴이라고 합니다. 만나뵙게 돼서 반갑습니다. 오늘 세미나의 주제는 영국 수소 혁신, 안전하고 지속 가능한 넷제로 미래를 위한 기술입니다. 영국은 수소 기술을 통해 안전하고 청정한 에너지 전환을 시도하고 있으며 오늘 이 자리에서는 영국 기업들의 혁신적인 솔루션과 전략을 직접 들어볼 수 있는 소중한 기회가 될 것입니다. 오늘 제가 서울에서 오는데 그 GTX가 굉장히 잘 되어 있더라고요. 근데 많은 분들이 아마 차량으로 움직이시는 분들은 좀 어려움이 있을 것 같은데 그래도 약속한 대로 세미나를 시작하고 더 많은 분들이 이제 세미나 진행하면서 오실 수 있도록 기대해 보겠습니다. 자, 그럼 첫 번째 발표를 시작하겠습니다. 크로콘 디텍션 인스트루먼트의 제로드 님께서 수소 산업을 위한 가스 감지 솔루션, 안전과 신뢰를 위한 핵심 기술이라는 주제로 발표해 주시겠습니다. 제로드 님 무대 앞으로 와 주시기 부탁드립니다. Could you, yeah, it's on your right, yeah. Thank you. 박수로 받아 주시기 바랍니다.
Thank you, Cindy. Do we have the slides here?
I think so. 여기
Just looking at the number
here
time.
as well.
Only here?
I mean for you.
Before me. Yeah.
슬라이드를 보실 수
Yeah.
있으신가요?
Yeah. No, it's okay. I'll take my. Sorry, just use my computer. It's okay. I think let's start. Anyway, thank you, Cindy. Thank you very much for the introduction. Good morning, everyone. Welcome to this session. First and foremost, I want to thank the DPT for inviting us to exhibit in this H2 meet in the exhibition. We are very glad to be here. And also thank you for the H2 team organizers, Jenny. Jiang, especially a special mention to Jiang, who has helped us through this whole process, and the team. Very grateful indeed from Crocon. So next slide. So who are we, Crocon? We were established in 1970, and Crocon has a rich heritage in protecting and saving lives through our gas detection solutions. Today, we have manufacturing bases in the UK, China, Italy, and the Middle East. And we have more than 200,000 safety systems installed worldwide. In the 1980s, we were acquired by the Helmer public listed company, a company on the London Stock Exchange on FTSE 100, which actually comprises of a group of life-saving technology companies engaged in safety, environmental, and healthcare sectors. And we have a combined total revenue of more than $1.5 billion pounds as a group. Today, Crocon is proud to be one of the top 10 contributors to the group's revenue. Okay. Apart from serving the clean and new energy sector, Crocon also provides our solutions in other vertical segments in oil and gas, wastewater, marine, and shipbuilding, among others. So we do have a very rich heritage in all these areas. We extend our expertise beyond the new and clean energy sectors. Right, now we turn to hydrogen. Safety and safeguards. I think we know this. Basically, the properties are actually light, colorless, odorless, and tasteless. And because of the properties, as well as the invisible flame, the ignition actually is quite fast at the volume of 4%. So we basically, it's very flammable, in other words. Yeah. And we also look at the asphyxiation, where actually if in a enclosed space, when you have hydrogen buildup, then you get a situation where you're not able to breathe and you can basically pass out. And for frostbite, that's the situation in the liquefied form. So look at this ignition. Yeah. So in typical gas hydrogen leak. In a typical situation like this, we have a hydrogen leakage. With the ignition, you get a fire, right? You get a fire started. And when you have no ignition and you have a gas cloud, that ignition will result in an explosion. And in the confined space, as I mentioned, you get asphyxiation. And in the open area, when it comes to an explosion, you typically have, of course, unfortunate incidents where people have passed on and also a destruction of property. So this is the kind of understanding of the risk that we face. And then in safety, the aspects, it's a light gas. So hydrogen is a light gas, less radiant heat, so you don't know unless you're close to it, you can feel the heat. And because there's no smoke, you need to have a lot of detection ready to be able to detect it. So the focus actually on hydrogen, there's a lot of misconception about hydrogen being more dangerous, but actually every risk exists in gasoline, natural gas, or other fuels. And hydrogen actually, if we are able to manage the safety aspects, we can actually have a successful adoption in this space. Okay. So this is a report of the database, Hydrogen Incident and Accident Report. And you can see that this is what they've seen in the space of reported incidents. And you can see the high incidence of explosion at 56%. And then fire is 28%, unignited release at 30%, and a near miss only at 3%. So you can tell that from here, it's really a very dangerous situation, and you need to be very wary of where you are with the detection part of it. So in terms of reported causes, typically what they found are actually valve malfunction, and leaking connections are the leading causes of hydrogen incidents. And what can be done about it is 50% of these incidents in the report says that staff, if they were trained and educated better, they would be able to mitigate the risks. And incidents reported as well as correction measures taken, and better systems design and material selection were adopted. So this is important where we go forward with this. And there are safeguards that we have in place. These are the broad scopes that we have. We'll go into the details about electrolyzers in a while. So if you look at hydrogen, two ways of doing it: prevention, so robust equipment design, that's very key. Regular inspection and maintenance needs to be done, and also training and the awareness of the staff. In terms of limiting the exposure, emergency shutdown system, the flow, restrictive flow, damage limiting building volume, as well as emergency exhaust ventilation. I think the other speakers will talk about this later. This typically comes under the H2 detection system, which I'll talk a little bit more in a short while. So in terms of detection technologies, these are the typical kinds of gas detectors are deployed to mitigate the risks in hydrogen. In terms of personal protection, you have one that you carry on with your PPE, your personal protective equipment. This you put onto your overalls, and this one will detect hydrogen, if there's hydrogen within your vicinity. And also for fixed gas, we also have this fixed gas detector and the flame detector that's able to detect hydrogen flames. And acoustic for leaks from pressurized sources. And this is perhaps the key, which I'll talk about in a later slide, that we can Crocon is able to give, a bespoke system so that you can design it according to what you require, and it basically is in the form of gas sampling system and measures hydrogen concentration in process lines. So apart from the detectors you saw just now, so the detectors, within the detectors, you would have the various kind of sensing technology. I will not go through all of them. Basically, these are the key sensing technologies are deployed. Catalytic electromechanical, MOS, MEMS, thermal conductivity, and NIDR. But NDIR doesn't detect hydrogen. The rest of them will have its own advantages and disadvantages. So you need to understand, we will work through with you in terms of what your requirement is, and then be able to advise which particular sensor goes into which sampling system. Okay? So in terms of applications, I think you have seen this. I think it's all around the exhibition, the whole hydrogen value chain. But we will focus in the next few slides in terms of the electrolyzer and how we actually mitigate risk in terms of this space. And we'll show you some of the deployments we've done for storage and transportation applications. So this is key. There's quite a lot happening here. So typically in the electrolyzer side of things, you have two systems, the alkaline electrolysis or the PEM electrolysis. The two different systems, but this is how we deploy. So the whole process will go through right to the end to hydrogen storage. And we typically recommend the detection on two bases. Yeah? H2 fixed detectors, which is typically top-mounted throughout the whole process, where you can see on the electrolyte side, after oxygen, hydrogen, the scrubber, and the compressor side, and eventually in storage. Now, this typically is top-mounted, so it's top-mounted on devices, and if it hits 0.4% detection, then you need to go into ventilation to prevent any disaster from happening. And also, for 1% volume of hydrogen detected, shutdown is recommended. Okay, so this is also where we deploy the different stages here. This is for alkaline electrolysis. This is for PEM electrolysis, right? You see that there are actually more deployed in this alkaline electrolysis process flow. And apart from the fixed detectors that we place in such a system, we also then have a sample system. And we can do this in terms of a bespoke basis, design it to according to your needs. And we are able to detect H2, O2 in H2, range between 0.2%, H2 in O2, with a range of 0.1% volume, and also refined H2 analysis with a range of 0.10 ppm. So this is what we can do in terms of protecting the devices. So what happens here is that the sample analysis that we just talked about, typically to detect H2 in O2, this is installed at the oxygen outlet pipeline. And why do we do that? It's to detect whether hydrogen has leaked into the oxygen stream. And also to prevent the formation of explosive gas mixtures. Typically in the specs, we would use the electrochemical sensor or the thermal conductivity sensor. And these are the range that is able to detect 1%, 2%, 4%, and also at volume 5,000 ppm, right? And also for O2 in H2, in the earlier slide where you saw the electrolyzers, we put it, we installed it on the hydrogen outlet pipeline, the downstream of hydrogen purification units to monitor the final product of hydrogen quality. So we do this to detect whether oxygen has leaked into the hydrogen stream and the safety and purity of the hydrogen, and also to prevent the formation of explosive gas mixtures. And here again, we deploy electrochemical sensors at a detection of 1%, 2%, and 4% volume. And trace O2. This will be installed after hydrogen purification treatment, downstream of the hydrogen dryer and upstream of the storage tank or hydrogen processor. This is where I put it, and final hydrogen outlet to confirm the product purity. So we do this again to detect residual trace oxygen in hydrogen and to assess whether the membranes are actually damaged or aging. Okay. Once again, you can see we deploy the electrochemical sensor at 0.10 or 100 ppm, parts per million. All right. This is a sample analyzer that we typically put inside the system. We are able to, this is just one of the samples that we've done. We are able to design it according to your needs and also depending on what the requirements are. So do come and talk with us if you need to. Just have 2 more slides. This is what we have done in terms of our experience on the storage side. You can see that this is a gas detector here in the yellow form, and the red are actually the flame detectors that are deployed. So this is a site for storage, and here are mostly flame detectors, but we have also a mixture of gas detector here. And again, in transportation, a ship and vehicles, the requirement that we've done as well for gas detectors, flame detectors, and here for the ship, more on the gas detectors. And for filling station as well, you can see it's actually built on top of it, where the filling station is, the gas detectors and flame to monitor from the sites. So this is our experience. We've done some of these projects, and also for testing platforms, we have done for this, this is electrolysis. This is for fuel cell testing platforms. You can see our detectors are actually in orange here, these 3 devices. So we do have a lot of experience in terms of hydrogen tests that we can actually help you with. And I think in terms of managing the hazardous portion of it, I think this is where Crocon can help. So if you are keen, please come by and see us at our booth at the UK Pavilion at 7C613. So thank you for your kind attention today. Thank you.
Thank you, Gerald.
Yeah, thank you.
원래는 저희가 Q&A 질문을 나중에 네트워크 때 하려고 했는데요. 혹시나 질문이 있으신 분이 있으실까요? 지금 발표를 굉장히 짧은 시간 안에 컴팩트 있게 해주셔서 저희 통역도 준비되어 있으니까요. 질문 있으신 분. 네, Gerald, because you've done a perfectly well-managed time, I actually ask if there are questions. Actually, there's one question. Can you get into the interpreter device? Yes.
I will use the English.
Okay,
It's
great.
okay.
Thank you.
I'm Junhyuk Jang in HDKSOE. I'm in charge of the liquid hydrogen carrier. So I'm interested in the hydrogen detector. So I wonder, someone said hydrogen is light, so it can be dispersed easily. But when the hydrogen is leaked, the hydrogen makes some fogs with the air, so it will be heavier than the pure hydrogen. So first, when the hydrogen is leaked first, the hydrogen will go down to the bottom, and then the hydrogen will be dispersed to the upper side, as far as I know. So I wonder, if we have to install the hydrogen detector to the bottom or upper side. So
It's
that's
on
my
the upper
question.
side. We typically deploy it on the upper side. And I don't think it's heavy. I think it's always rising up. So in terms of where the situated gas detector is recommended to be on the upper side, on top. Yes. Yeah.
Thank you.
Welcome.
Great.
If you're keen, please come to our booth. We'd like to discuss with you more. Maybe you have more designed requirements for your installation, and we can always discuss more with you there. Okay, thank you.
저희가 밑에 영국 부스가 있습니다. 퍼블리언이 있습니다. 그래서 구체적인 질문은 한번 방문해 주시면 그때 상담해 주시면 될 것 같습니다. 네, 감사합니다. 다음 발표는 플렉시탈릭 UK에서 알렉산드로 카발리께서 진행해 주십니다. 발표 주제는 수소 산업의 안전성과 신뢰성을 높이는 혁신적 실링 솔루션입니다. Alexandra, you're ready.
Thank you. Good morning. So my name is Alessandro Cavalli. I am the Business Development Manager at Flexitalic, looking after our activities with new energy technologies, which obviously includes also hydrogen, or let's call it new hydrogen technologies. In the next 15-20 minutes, I will talk about the ceiling challenges of hydrogen technologies, part was covered in the previous presentation, so there's going to be some overlap. But then I will focus on something different, that is actually preventing leakages from occurring rather than detecting afterwards the leaks. As also was said before, when we talk about hydrogen, we are talking about many different technologies, applications. So I will focus on two specific sectors, let's say. One is high temperature hydrogen technologies, and the other one is hydrogen pipelines, or piping, better. And then something slightly different, that is, how do you make sure that you are applying the right compressive stress in your gasket or on your gaskets when you're working with low temperature electrolysis stacks like PEM and alkaline. Before entering really into the topic, a couple of words about FlexiTallic. For those of you not knowing the company, we are a leader in static sealing solutions, from the engineering, the development, the design, and then the manufacturing of gaskets. We are present worldwide, both with our manufacturing, but also distribution and our channel partners all over the world. We are not only making the gaskets that prevent the leakage or the sealant that prevent the leakages, but we are making also softwares and offering services to make sure that the flange connection is leak-free. So we look at the total joint integrity. As you can imagine, since we are working with gaskets, with sealants, we work with several different industries, and we have been working with hydrogen for very long time, because what we can call as a traditional hydrogen, that is the one that is produced and then used in chemicals like ethylene or refineries for the hydro treatment, but also in ammonia production plant. So this is what we could call traditional hydrogen, but it's now more than 20 years that we have been working also with what we could call new hydrogen technologies, for example, fuel cells and electrolyzers, especially high temperature ones. As a company, we are heavily focused on R&D and innovation, and we have the mission of making the world safer and cleaner. And since safety is paramount for our company, I would say that we can start from this slide and look at safety when we talk about hydrogen. Exactly, I would say the same as we have seen before. When we look at previous accidents in the hydrogen sector, you can see that most of the issues were caused by leaking connections or leakages from valves. Now, it's true that quite often the cause was due to the human intervention or how the installation was done, but part was also due to the selection of the components and of the materials for that specific application. And the problem is that when we are working with hydrogen, of course it's a small molecule, so high tendency, or it can easily leak from connections. And then, as we have seen before, if you have a leakage, consequences can be quite severe because it's highly flammable and also highly explosive. On top of this, difficult to detect simply by senses because it's colorless, odorless, tasteless, so we need to use devices to actually detect a leakage. I think that what really makes it even more difficult is that we are here, we talk about hydrogen, but hydrogen is an energy vector, it's a chemical feedstock, so we are talking about several different applications from production, transport, storage, end use. So it's really a world, the world of hydrogen, which means that we have many different operating conditions in terms of temperature, from cryogenic, the lowest you can go, minus 253 Celsius, up to extremely high temperature, even 900 degrees Celsius. And the same goes for pressure, so from relatively low, nearly ambient of some type of electrolyzers, up to extremely high in hydrogen storage. On top of this, we talk about hydrogen, but we also need to take into account all the other gases and liquids that are involved in the hydrogen sector, for example, from methane, ammonia, liquid hydrogen carriers, and also, for example, ultra-pure water or potassium hydroxide solutions used in low-temperature electrolyzers. So it's not easy to talk about leakages and gaskets in general, and this is why I think it's better if we can focus as done also before, on some use cases, as I said, high temperature and hydrogen piping. Starting from high temperature hydrogen systems, here you can see various types. So we can look at ceramic membranes for hydrogen production or filtration. You can look at catalytic pyrolysis for what is called turquoise hydrogen, or also hydrogen from biomass gasification. These are all very high temperature processes, which is something that is, the high temperature is something common also to the traditional way of making hydrogen, that is steam methane reforming. So the challenge is, obviously, is the high temperature. It's not that easy to find materials that can withstand for a long period of time this operating condition. And then you need to keep in mind that when you are at high temperature, things move, things relax. So if you have a flange connection, what will happen is that with thermal expansion, your flange might not be stable, and there can be some relaxation of the metal, so the stress applied on the gasket might not be constant. Quite often, also, there are thermal cycles, so these systems do not continuously operate, but they will be turned off, turned on again, and the temperature will fluctuate. And last, depending on which specific technology we are looking at, there can be some corrosive media involved, for example, pyrolysis oil. Now, to address these challenges, Flexitallic developed a family of material called ㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡㅡ. This family of material is based on restructured silicate, which makes the material itself inert, and it's resistant to oxidation. So different from other sealing material like graphite, even if you are above 350, 400, 450 degrees Celsius, the material does not undergo oxidation, meaning that it remains stable over time. Also, because it's based on restructured silicate, the material is quite inert, so it's compatible from a chemical point of view with a wide range of material. And since there's no reaction going on, you can be sure that for long term you have proper service condition at high temperature. As I mentioned, it's a family of material, so you can find it as a semi-metallic gasket, packing for valves, and different type of application that you might be working with. Remaining in the world of high temperature applications, I would like to focus on solid oxide cells, and that is because it's one of the technologies that is receiving more attention in these days, partially because they are reversible. So when you use them as fuel cell, you can generate power from various fuels. And when you use them as an electrolyzer, you have the highest efficiency in generating hydrogen. Again, they are high temperature technologies, so it's not easy finding a material that can withstand this temperature for a long period of time. We are talking about a stack, so you have several layers of ceramic material, so you can imagine that you cannot apply a very high compressive stress. Also in this case, you might have thermal cycles. And last, even if we are talking about high temperature and nickel catalyst, so more resistant catalyst to impurities, still there is the risk of poisoning coming from the gasket itself. Again, we have a solution for this. Basically, from the family of vermiculite, we developed some specific grades for solid oxide cells. In this case, what you find in the material is only exfoliated vermiculite and steatite. There's no binder, so basically you are removing the risk of poisoning from the gasket itself. We make it in various thicknesses, from 0.3 to 1 millimeter, which makes it suitable for application inside solid oxide cell stacks. And it's a highly compressible material, so it will be able to compensate for manufacturing tolerances of the other components in the stack. At the moment, this is the most used compressive gasket in solid oxide environment, and this is because of these unique properties. And it can be used in the stack, but also in the hot balance of plant of the system of this technology. We change completely from high temperature, we go to ambient, and we have a look at hydrogen piping. Now, we said it before, it's a small molecule, which means that the gas can more easily escape. And as we said, it's flammable, which means that ideally you want to use a fire-resistant gasket. Mentioned before, very broad pressure range. Imagine a pipe from an electrolyzer operating at just a few bars compared to a pipe that is transporting hydrogen much higher pressure. And as you can see in the picture, as you know, there is, let's say, the tendency or the desire to move these hydrogen plants close to shore or even offshore, where you have availability of renewable electricity and also of water. These represent a risk of corrosion. So hydrogen itself is not corrosive for the gasket, but the moment you have this installation offshore or near shore, the salinity of the environment might cause corrosion in your connections. Again, challenges, we created some solution. In this case, we are talking about a material called vermiculite. This is the tightest sealing material you can find out there. So when you compare it with traditional type of sealing material, graphite, PTFE, vermiculite gives you better sealing performances. And it also is better, for example, than PTFE because it is fire safe. It is better than graphite because it prevents the galvanic corrosion you might find in environments like the one we've seen before. It is also a material that you can consider future-proof in the sense that it does not contain any PFAS. You know that these days there is a lot of discussion on PTFE and PFAS ban. So this material does not contain anything of this. And it has a very broad operating condition, from cryogenic up to 260 degrees Celsius. And again, since it is used in different type of gaskets, it can be used for different pressure ranges. We now look at the last part of this presentation, that is how to make sure that you are properly applying the right amount of stress on your gasket and overall in the whole stack. As you might know, if you take an alkaline electrolyzer or a PEM electrolyzer, what is done today is you take a wrench and you just torque one by one the different tensioning rod. The problem is that when you are torquing, you are not sure about the compressive stress you are applying. The other problem is that when you are torquing one rod, there is a crosstalk between that rod and the other. And since you are doing one by one, you are not ensuring that everything is going down in a parallel way. There are solutions, so instead of using torquing, you can use tensioners. There are tensioners out there in the market. The problem is that they are not designed for electrolyzer stacks. So the space that you have available between the different rods is not that much. You cannot fit standard tensioners. These tensioners are really not designed for very long rods like the one you find in electrolyzer stacks. And quite often they have some spillage of the oil used. and this is a risk for poisoning of the stack. Also in this case, we identified some challenges and we came up with solutions. What you can see here, these are two systems that we developed for tensioning stacks. So we are moving from torquing to tensioning. In this way, we know exactly what is the stress that we are applying on the gasket, and we make sure that everything is being compressed in a parallel way. At the same time, everything remains uniform. We know exactly what is the load applied, and as you can see in the two pictures, this is not something off the shelf that you buy. It's something that can be customized. So the design is flexible, is the knowledge and the technology behind it, but then we usually discuss with customers how their stack looks like, and we can make it exactly based on their requirements. Not only in terms of the shape, the dimension of the tensioning system, but also in terms of how long are the rods or what are the important parameters for your assembly. For example, when you are in high volume production of stacks, we can ensure that you're able to close your stack in just 5 minutes. If you have a very big stack, then we can make the system capable of compressing for more than 20 centimeters your tensioning rod. Last, since this is specifically developed for electrolyzer stacks, we make sure that there's no spillage of any oil used in the hydraulic tensioner, so you can even use it in clean rooms, which quite often is the case, especially with PEM electrolyzer, where they first get a first compression step in the clean room, and then they complete the compression outside. Of course, this is extremely important because you need to know what is the stress you're applying on the gasket, but you also need to make sure that you are using high-quality sealing material, high-quality gaskets. Now, I know that the presentation was very broad. I covered the challenges, high-temperature technologies, solid oxide, then the piping, the tensioning, so it was many points being touched just on the surface. If you want to know more, if you want to discuss your application, we are in the UK booth, so you can find it in, 7C61. We are then the booth number 4. You're welcome to come and discuss your needs. Thank you.
감사합니다, 알렉산드로님. Would you like to take any questions?
If there is any question, yes, more than welcome.
혹시 질문 있으시면 지금 한두 개 정도 가능하거든요. 아니면 연구관에 직접 오셔서 방문하셔서 상담하시면 될 것 같습니다. Okay, great. Thank you. 자, 세 번째 발표는 울람코의 폴 터너 기술 이사님께서 넷제로 전환을 위한 듀얼 연료 수소의 역할, 디젤에서 수소로의 미래 모빌리티 혁신을 주제로 발표해 주시겠습니다. Paul, please. Thank you. 박수로 맞이해 주시면 감사하겠습니다.
Hello, and thank you for coming to listen to the talk. I'm going to go through initially who Yelumko are. I then talk a little bit about my, bees in my bonnet about the transition to zero and how we have to transition rather than step. And then I'll go through some of the solutions which we're providing to some of our customers to allow them to actually transition through to zero emissions. Okay. Let's see, be moving on. Not quite pressing the button right. Okay, Yelemco is a company which is developing applications for hydrogen. So we're looking at the transport industry, the off-highway sectors, looking at utility vehicles, and vehicles which operate in specialist areas like airports. We started in 2014. We spun out of a company called Relive Technologies, which later became CMB Tech. We started off with a hydrogen dual fuel technology, which we've been applying and are still applying regularly to customers. But whilst we're going through that transition, we've been developing some fuel cell technologies and some hydrogen IC engines in hybrid configurations to support some of the applications. And once we've got some of these applications in the field, we found there's a big hole in the marketplace for getting hydrogen to vehicles. So we've developed a hydrogen Bowser, which actually takes the hydrogen to vehicles which are operating off-highway. So we sit in the hydrogen value chain as a system integrator, providing our customers with various different hydrogen applications in the transport sector and a little bit on the refueling. We don't get involved in electrolysis or in the production of hydrogen or in the general distribution of hydrogen. And we're a very experienced company. We have great experience in finding out what our customers' requirements are and being able to provide solutions that suit that customer. We are well up to date with all the different standards and regulations we need to use for hydrogen and hydrogen transport in the various different guises, whether that be maritime, whether it be off-highway or on-highway. We have some economic models which go through how you're going to get a return on your investment. Some of that is quite challenging these days with hydrogen pricing, but it depends on how you're marketing and what is your need to decarbonize. Within the European field, we are up to date with all the hydrogen supply, where we can get the hydrogen from, and we can support our customers in actually buying the hydrogen. And we have some patented software which allows us to do gas detection systems using different types of pressure balances and monitoring of hydrogen on board the vehicle. So we do it all by pressure difference. And we have a track record of delivering applications for our customers successfully. And this is just a range of some of the things which we've been doing for our customers. We've got the hydrogen dual fuel technology, which is our core technology. We've been developing fuel cell range extenders, which allow us to be able to plug and play into electric vehicles. So if you have an electric vehicle which isn't doing the job you need it to do, because it doesn't have the range or the power on board, we can add a hydrogen fuel cell and all the associated storage systems to your vehicle. This is showing a small one, but I'll show it a bit further later on. We are working with various fuel cell providers, including Hydrogenics and Toyota. And we developed a hydrogen IC engine as a low-cost application for hydrogen systems. It's a hybrid system, so we use some of the advantages of the hybridization to allow us to avoid some of the NOx issues, so we can run these engines with zero emissions. But I'll come on to some of those and show you some of those applications as I go forward. But the one thing I really want to talk about is the transition to zero. And why I believe we have to transition. We can't just do it in one big step. So one day we're all diesel, and next day we're all hydrogen or zero emissions. And we get a lot of pushback saying, why isn't your technology completely zero emissions? And I often have to say to people, don't let best be the enemy of being better. So we have a scenario I think we're all aware of, the chicken and the egg. If I've got a hydrogen refueling station and I've got no vehicles to come to it, the station doesn't open, doesn't stay there for long, it gets closed. If I go and buy some vehicles and I've got nowhere to refuel them, I can't use them, they get parked. They become redundant assets, waste of space, paperweights. So we need to find something which allows us to be able to use hydrogen when hydrogen is available, encourage the deployment of stations, and if hydrogen isn't available, the vehicle, the asset, can still do its job on the traditional fuel, whether it be petrol or diesel or CNG. So we need to be able to allow ourselves to transition to zero emissions. And we've been doing that using hydrogen dual fuel. So we have an entry standard for hydrogen dual fuel. This standard allows us to put hydrogen onto a vehicle, and typically that gives us something between 30 and 40% reduction in CO2 on that vehicle over its daily duty cycle. Peaks can be up to 95%, minimums can be almost at 0%, but its average is about 30 to 40%. And this allows companies to get to know what hydrogen is, explore what they're doing with it, learn how to refuel vehicles, learn how to deploy it, get their operators comfortable with hydrogen, get their drivers comfortable with hydrogen, get their maintenance teams comfortable with hydrogen. And then we've been working with some OEMs, and some of our competitors have been working with the OEMs to develop OEM-based hydrogen dual fuel solutions. And here they get an average of around 60 to 70% of their energy from hydrogen. And a notable one of that is C&B Tech with their cooperation with MAN and Volvo Penta. With MAN engines, they've got some big V12, 24-litre engines running in their Windcats, and they're getting between 60 and 70% utilisation of the hydrogen, but displacing diesel. But once we've managed to get systems in place, we've got the infrastructure starting to be reliable, end-to-end. Wherever you go with the vehicle, you can refuel. Now we can start to introduce monofuel applications. That's fuel cell. And I can tell you now, I used to drive a fuel cell Mirai. Beautiful car, fantastic. I had to give it back to Toyota because somebody closed the only station in the southeast of England. I couldn't use it. I had to give it back. We tried to go one jump and it doesn't work. We need to be able to transition. So once we have an end-to-end system for hydrogen, we can go to the monofuel solutions. That's fuel cells, hydrogen ICEs, and they can now refuel wherever they need to go. So I think we need to look at this transition stepping stone rather than trying to jump. Because every time we try to jump, we hit another hydrogen hype with a hydrogen crash. So we need to do it in a progressive way, like battery electrics did with the hybrid. Toyota as pioneering the Prius, and eventually we got to the zero emissions electric vehicles. Another thing I keep doing, but your vehicle just isn't zero emissions. It's not saving enough CO2. But there's a cost as well. Fuel cell electric trucks, for instance, are very expensive pieces of kit. All the power electronics, all the traction motors, the batteries, the hydrogen system, the hydrogen fuel cell, all adds up to give you a very expensive application. For 3 fuel cell trucks, I can do over 40 dual fuel trucks. I can save 450 tons of CO2 compared to about 90 for the same value of pounds, dollars, whatever you want to use your currency. So I can do a lot more CO2 saving with my 30 to 40% than you can with 100% saving on a hydrogen fuel cell vehicle. Balance isn't quite the same if you've got a hydrogen ICE, but most people are trying to jump into that hydrogen fuel cell sector. So we can do a lot of savings by going dual fuel and getting the transition working. Let's go on. Oop. Okay. And just to jump back to that, couple back. Now, I'm struggling with the clicker. These are some of the applications of dual fuel. There we go. When we put dual fuel on, it's quite cheap because the main cost is the hydrogen tank. Once we put the hydrogen tank on, we've got a regulator or two regulators, and we've got an electronic control unit and a display, and that's it. The rest of it's done by software, and we just inject into the engine and we can operate it. We can apply it to a new vehicle in about 2 weeks. And the same type of vehicle being retrofitted, we can start turning those around in about 2 days. So it's a very quick and easy way of getting yourself into the marketplace. This is one of the examples we've done. This is a refuse collection vehicle. This is a road splitter, just what you need here today. This has been operated by Aberdeen. Aberdeen have actually got over 40 vehicles now running this technology. Go on. No. Just keep trying this. There we go. That's another waste disposal vehicle. This is a food waste collection vehicle running on hydrogen into the tanker. This one is up on the roof. Smaller vehicles as well. This is a Ford Ranger converted to run on hydrogen, dual fuel. Here's a water tanker running on hydrogen dual fuel. Even tractors. This is a Massey Ferguson tractor, but we've also done some Case New Holland tractors. There's about 10 of those operating in Holland at the moment. And more recently, we've been working with off-highway construction equipment to convert 360-degree excavators, 40-ton dump trucks, piling rigs, heavy load vehicles, and these are running hydrogen dual fuel, getting around the 30% reduction in CO2. Sorry, his clicker is messing around. Here's one of the vehicles actually really doing some heavy work. As you can see, there's a lot of load there. We've tried fuel cells in these things, but it really doesn't work. They use too much energy. And to support those off-highway machines, they can't track to a refueling station. So we developed a Bowser for one of our clients, and we're actually doing these for some other people now. And these are actually taking the hydrogen to the excavators on the site. This is a four-wheel drive truck, which has got a hydrogen storage on it, a compressor to compress it up so we can get maximum transfer pressure, and they can refuel vehicles to 350 bar in about 4 to 5 minutes of turning up to the vehicle. Yeah, come back here. You didn't press it. This is another refueling system we have, and this is to allow us to take small quantities of hydrogen around to different applications. We typically use this for when we're doing a setup or a calibration of a vehicle. There we go. And the other things we are doing to make sure we're ready for once we get a good infrastructure in place is to develop the fuel cell range extender and the hydrogen ice. There we go. Here's one of our hydrogen ICE vehicles. This is a hybrid drive train, and it's been operating with the RAF for probably a year and a half now. And here it is at Riyadh, pulling around an F-16. Low carbon, high carbon. Another application, again, working with the RAF. This is another high ice vehicle. So it is running a hydrogen monofuel engine, and it's running in a hybrid configuration. A little bit more battery on this one. So it's got around 30 kilowatt hours of battery. So it can do a bit more pure EV operation before the range extender has to come in to do the charging. Yeah. Nope. Let's get back. Nope, doesn't want to go back. There it goes. Another application here is the fuel cell. This is a bicycle fuel cell. This is an ambulance with a fuel cell. We're developing this now with the Toyota Mirai fuel cell. And finally, just showing you a fire engine. This is a render, not the actual thing. The body is actually going onto it, actually this week as we speak, with the fuel cell onto the electric chassis, going onto I think it's a DAF chassis, electric chassis. And that'll be operating hopefully by the end of this year with, well, the end of this year, middle of next year, with Oxfordshire Fire and Rescue Service. Thank you very much. If you want to know a little bit more, come and see me on the UK Pavilion, or if you want to just contact Ulemco about what services we can offer, you can contact Amanda or myself and give you a business card. Thank you very much.
Thank you, Paul. 혹시 질문이 있으실까요? Do you have your interpreter device? 여기 마이크 좀 주시겠어요? 여기 질문이 있으시다.
Hello, thank you for your presentation. So I'm from Hyundai Motor Company. So as you know, under the definition of zero emission vehicle in European Union regulation, so that is a single hydrogen, single fuel internal combustion engine can be defined as a zero emission vehicle. So I would like to know why Ulemco is focusing on dual fuel internal combustion engine. And in addition, I'd like to know isn't there any plan to develop hydrogen single fuel internal combustion engine?
First of all, our main target is for the hydrogen dual fuel because we need to transition to zero. If I go put vehicles on the road today, certainly in most parts of the UK and in quite a few countries in Europe, the vehicles would sit idle if they were fuel cell vehicles. They could be used for demonstration trial and then they get parked up. And that's no good for the transition to zero emissions. We need to be using hydrogen. We need it to be out there. We need people getting used to it. We need it to become normal. And therefore, we need applications that will work when hydrogen is available. When hydrogen isn't available, which it often isn't, we can still use that asset. It's not a waste of money to the company that's bought it. It can still do its job on diesel. Classic example is Glasgow City Council bought 20 road gritters from us, all on hydrogen dual fuel. Their hydrogen supplier, after the first week, stopped supplying them hydrogen. They haven't had hydrogen now for nearly 2 years. Hopefully we'll get it next year. Those gritters, if there had been fuel cell or hydrogen ICE, would have been parked up and not been able to use, and somebody would have got lynched at the local authority. In this case, those vehicles carried on doing the work, doing it on diesel, and when the hydrogen becomes available early next year, they will go back onto running hydrogen. So that's why we've concentrated on hydrogen dual fuel, to allow us to take the transition from diesel to zero as a transition. We are working on hydrogen monofuel, and the application that you saw towing the jet fighter is a hydrogen monofuel engine operating in a hybrid configuration. And we find that gives us the ability to run without a catalyst on the hydrogen ICE of any type, and doing our speed transients using the electric motor to transient the engine between these different power speeds. And then we just do low transitions, which are slow transitions, avoiding the transient NOx, which we could generate if we were running it as a variable speed engine. So we are doing both dual fuel and hydrogen ICE, but we see the transition is needing something which is going to allow you to take the little steps to zero, not trying to do it all in one big jump.
Thank you, Paul. 추가 질문은 저희 그 연구관에 방문해 주셔서 해주시면 감사하겠습니다. 자, 마지막 발표는 얌나의 엄영선 매니저님께서 그린 수소 암모니아 시장 창출을 위한 전략, 글로벌 생산과 수요 연결을 주제로 발표해 주시겠습니다. 매니저님, 감사합니다. 박수로 맞이해 주시기 바랍니다.
Hello, everyone. Thank you for being here today. My name is Youngsan I'm Business Development Analyst at Yamna. And today I'm pleased to introduce you to the company Yamna, what we are doing as green hydrogen and ammonia project developer in the UK, and what we are doing to create a viable market for green hydrogen and ammonia. So Yamna is a global green hydrogen project developer based in the UK. We are headquartered in London, but we have a global team who are scattered all around the world. And we focus on developing and investing in projects all around the world, especially in the location where it makes sense to produce low-cost green molecules and to deliver it to our customers. We have several projects under development. Our most advanced project is in Oman, but we also have other projects in Brazil, Morocco, and India. Yamna is backed by a UK private equity fund called HiCap. HiCap is a fund that is specialized in hydrogen, and they invest across the entire value chain of hydrogen, from production to delivery and uses. And they're actually, their cornerstone investor is JCB, who is the global construction machinery manufacturer, and they are the potential consumer of hydrogen. So our most advanced project is in Oman, Salalah, where we are developing a 1 million ton green ammonia project together with our development partners EDF and J-Power. And currently the targeted COD is 2030. So now that I've explained a bit about what Yamna is and what we are doing, I want to open a discussion on what do we need in order to create a viable green hydrogen and ammonia market. And so there has been a lot of bad news recently where projects has been delayed or canceled, and there's delays in the regulation implementation. Of course, in Korea, there was the suspension of the CHPS auction. So not so good news around. However, I do still believe, and we believe that there is a market because, first of all, the transition to net zero emissions and decarbonization cannot happen without a hydrogen used in the hard-to-abate sectors. So we've been talking to different customers in different sectors, such as the steel sector, refineries, fertilizers, shipping, and all of them have been saying that they have a plan to use hydrogen, and they are prepping themselves to use hydrogen when it comes to the right time with the right pricing. So we believe that there isn't enough demand. And also on the supply side, there have been a lot of projects announced past few years. I think at the IEA, they published that there's over 2,000 projects all around the world that has been announced. Of course, not all these projects will materialize, but it shows that there is a sufficient supply pool ready. So it's all about the timing and the size of the market when it all comes together. And there is this famous curve of adopting a new technology into a market and how it can be a mature market. And for now, I think past few years has been the hype of the hydrogen market, whereas now we're going to more of the disillusionment phase. The question is whether that are we in the upward side of this disillusionment process, or are we still going to more of a moment of realization phase? Unfortunately, I cannot give answer to this because I'm not a fortune teller. However, we do see a way that in order for us to move from that red box to a green box, there needs to be three solutions to this problems that we have identified, which is first the price, that there is a cost disparity between the production cost and the customer's actual willingness to pay. Second is the value chain infrastructure, where often case the production sites are located far from the demand centers. So there needs to be a seamless delivery from the production site to the customer site. And this needs the appropriate export-import infrastructures, the pipelines, the shipping, and all of these coming together at the same time. And last but not least, the new solution for offtakes, because not all offtakers are asking for the same thing. You need to have a fit solutions for each of the market, the regulations, the sector. So it's really important to understand what the specific need of each customer is and to tailor our approaches according to that. So I think in a way there needs to be four pieces that needs to come together in order for this hydrogen market to work. First is the knowledge on regulations, what exactly the targets are, what applications that are going to be used or demanding the molecules, and so on. The second piece is the relationships, actually talking to the people, to off-takers or traders who are going to be buying your molecules. And of course, there's the commercial and technical parts where you need to optimize your strategies based on the knowledge and the relationship that you have built. So based on those verified outcomes or strategies, you need to fit your, let's say, commercial risk allocations or technical sizing of your storage or your vessel size and so on in order to tailor to those findings that you have in the market. So maybe it's easier to give you an example on how these four pieces work together as a development engine. I've been mainly working on the Korean market, especially the CHPS auction, where I've been talking to the power generation companies and the traders to participate in this year's CHPS auction. And to begin with, at Yamna, we already knew that there was going to be a clean hydrogen power generation auction in Korea, that the volume will be around 3 terawatt hours, and that they need to import green ammonia from overseas in order to co-fire into their coal power plants. However, it was a bit difficult to penetrate into Korean market. As you know, there's the language barriers, and public gencos, they have already worked with existing Korean companies. So it's quite difficult to how to knock on their door and actually get them onto the table to have discussions. So it was actually, since I have a Korean background, it was quite easier for me to ask them for a meeting request and then to hear them out on what exactly they're looking for, what are their plans, and let's say what kind of price expectation that they're having. So based on this relationship buildings, we were able to find out that the Korean market is quite sensitive on the ammonia price. And also the delivery is quite a big issue because Korea is surrounded by oceans and that you need to deliver it inevitably by ships. So we need to have a customized strategy for how much volume ammonia that they want to offtake, at what price, and how we're going to deliver it in the short period of time, which the COD was around 2029, 2030. So based on all of this months of discussions, negotiations, and optimization process, we've been successfully having participated in the CHPS auction. However, unfortunately, as most of you know, the auction has been canceled last minute. So there is still a question mark around how it will unfold. However, we do not think this is a bad sign because in a way Korea is revisiting its decarbonization strategy. And of course, ammonia co-firing is still emitting some emissions from the power generation. So in a way, I think it's a good time to pause and revisit all of our strategies and to see if there's any new partnership that can be created based on the new plan that Korean government announces. So these are the main markets that Yamna is currently focusing, not only in South Korea, but also in Japan. There is clean hydrogen power auction called LTDA, and also a CFD scheme, which is more focusing on the hard-to-abate sectors. We are also looking into the European market, where we are in active discussion with different customers in different sectors, such as steel and trading mostly. And also in the global scene, there is the shipping, where also the IMO has been delayed for another year. However, we do see a market in the bunkering side as well. So we are continued to monitoring in these global hydrogen and ammonia markets so that we can deliver our cost-competitive molecules to the needed customers in a timely manner. That's it for today. Thank you for listening. We also have a booth in the UK pavilion, so feel free to visit us. And also you can connect me on LinkedIn, and I'm happy to discuss further and introduce to our initiatives. Thank you.
감사합니다. 자, 그 매니저님 말씀하신 대로 혹시 추가 질문이 있으시다면 현장에서 아마 끝나고 얘기하셔도 되고, 혹은 그 영국관에 저희가 7홀에 위치해 있거든요. 그곳에 오셔서 직접 자세한 사항 상담하시면 될 것 같습니다. 그럼 오늘 세미나에 참석해 주신 모든 분들께 감사드리고요. 앞으로 또 영국과 한국 간의 수소 협력이 더욱 확대되기를 기대합니다. 감사합니다.